We can determine the look of this tissue before we even see it. We know from the name that this tissue is going to have layers. It's stratified. And we also know from the name that it's going to have egg-shaped cells, squamous. We are also prepared to see these egg-shaped cells from the top down or looking at them from the side. We will be viewing them in a cut that shows them from the side. These two pictures on the left are linings of the vagina, which is stratified squamous, and these two pictures are created with two different stains. The purple stain in the middle, it's a more common stain that we'll be seeing that dyes epithelial tissue that characteristic purple. But down here on the left, the epithelial tissue is dyed red. And we'll see this stain occasionally. It's actually a combination of three stains, and it's called Mason's trichrome. You can see all the squamous cells in both pictures with many, many, many layers stacked up on top of each other. Some of the cells still have their nuclei, some of the cells don't. This picture on the right is a little bit more difficult. It's a picture of the epidermis of skin, and this was bad of me. I have not included the lumen in this picture, which would actually be up here. This would be the lumen up here. And you can see this pink stained picture down at the bottom. That's actually the connective tissue that the epithelial tissue is attached to. All right, so this top layer here is a layer of about 30 to 50 different layers of dead, flattened cells. This layer down here, which has some valleys and hills, this is a layer of about 10 layers thick and is a layer of live, plump, keratin-filled cells. So sometimes the same epithelial cell can look different depending on its stage of life. And this reminds you that epithelial tissue does really fast mitosis. And so you might see cells in different stages of life and death. And those stages can determine the cell's ability to take up stain. There are not many examples of stratified cuboidal in the body. Well, not many good examples. It's really hard to see the cuboidal shapes of cells with stratified cuboidal, and it's really easy to see their circular shaped nuclei. But this brings up a common misconception for students. It's usually at this point that some people are like, I think I've only been looking at nuclei. And I've totally been wondering what the heck you've been talking about when you talk about shapes, because everything looks circular to me. That's okay. That's really common for people to realize that at this point. Remember, the nuclei, they're so tempting to focus on because they take up that stain and they get that purple color and they're consistent through all the pictures, right? So nuclei are only nuclei. They all look round. So here, it's hard to see the cuboidally stacked cell shapes, right? But trust me, these pictures, they do have two layers. This tissue, simple or stratified cuboidal, it tends to line ducts and passageways. So we'll see it in organs that have fluids that might be spilling out onto surfaces that lead to the outside, like mammary glands and salivary glands. Sweat glands. You might connect to the nice round shape of the duct on this picture on the right here, right? Because it's like a straw or an opening through which fluids are flowing. Ha! You thought this slide was going to be stratified columnar. It's not. It kind of is, kind of. That's what pseudo means in the prefix of this word here. It's kind of stratified. Pseudostratified columnar has columnar-shaped cells, and they look stratified, but they are not. They're not. That's not many layers there. I know it looks like it, but it's not. The basal surface of each cell touches the basal layer, touches that basement membrane, which is like the barrier between the epithelial tissues and the connective tissues below it. This tissue really asks you to think of how these cells would look in a 3D presentation, right? Because here in a 2D slide, it's hard to visualize that. These column-shaped cells are not lined up in a row, right? They're not like that in simple columnar. They're all tangled together, like this damn wind chime that I have that has these strings of little bells hanging. I fight with it every summer. Another way, a student told me this, another way to think of pseudostratified columnar is a collection of really tall buildings, all columns, that have kind of fallen down due to an earthquake, King Kong, whatever force of destruction you like, but they all maintain their foundations with the ground. So they're kind of like toppled all over each other. These slides here are from the trachea, and they all have a feature on them that we will not see on any other epithelial cells. These all have cilia on them. Cilia are like little projections, much smaller than villi in the small intestine. And cilia, they all wave in a coordinated fashion. And in the trachea, they move mucus superiorly. So these cilia, they're kind of like a mucousy shag carpet that waves in the wind. And so to make the name of this tissue even more complicated, its name is pseudostratified ciliated columnar epithelia with mucus cells scattered between it. I just want to highlight some of them over here on the left. Transitional tissue, transitional epithelial tissue, lines the urinary system pretty much, found only there. It's not really found in the kidney itself, but it begins where your ureter drains the kidney, continues to line the ureter all the way to the bladder, lines the bladder, and then lines the deeper part of the urethra that leads the urine to the outside. This tissue is given this name transitional because the cells, all of them, are able to change shape, unlike other epithelial tissues where the cell is it's a fixed shape. A hallmark of this tissue is dome-shaped cells against the lumen, which you can see here. You can see a bunch of them over here. When these urinary organs stretch, like when the bladder is expanded to accommodate urine, all of these cells become stretched, so they appear much more squamous in shape. Transitional epithelia, it looks stratified, and it is, but the cells toward the lumen will have a more dome shape and a more squamous shape, and when relaxed, they can even look cuboidal in shape. In short, the cells that are deep, they can also look columnar in shape when relaxed, but when stretched as much as they can stretch, they can look squamous in shape. Just look for the dome-shaped cells lining the lumen. That is a dead giveaway for transitional epithelia.